So on this video, I want to explain the even ones, but you guys are going to have to do all of them, okay? Number 2, we are distributing one term at a time. So I want to go with the x times x, that is x squared. X times 4, that is 4x. Now that I've distributed the x, I'm going to distribute this positive 7. Positive 7 times x, that's a positive 7x. And positive 7 times 4 is positive 28. Now, I'm not stacking them up. You could stack them up, but when you have a binomial times a binomial, you only get 4 terms. And if you're going to be combining anything, it's going to be the 2 middle terms anyway. So that's why I don't stack them up. It's really unnecessary. If you want to stack them up, go for it. That's fine. But anyway, the 4x with the 7x, that becomes a positive 11x. And the x squared comes down, and the 28 comes down. And we're done. Let's move on, number 4. Number 4. Distribute the a times a squared. A times negative 6, negative 6a. Distribute now the plus 5. Plus 5 times a, that's positive 5a. Positive 5 times negative 6 is negative 30. Those middle terms, you could combine the negative 6a with the positive 5a, and you're going to get negative 1a. And of course, you just bring down the a squared, bring down the minus 30. And that 1 in front of the a, you don't really need that 1. You could just erase it and leave it minus a. But you could put the 1 if you want. I think on the back, it's only going to have it as minus a, not minus 1a. Either way, it's correct. And again, on these, I'm just simply writing them out from left to right. You could stack them if you want. Let me show you. On number 6, I'm going to stack them, even though it's not necessary. 2x times 2x, well, that's 4x squared. 2x times 4, that is a positive 8x. Now, when I distribute negative 9 times 2x, that's negative 18x. So what I'm saying about stacking is you could write the negative 18x right below the other x term, because that's what you need to combine anyway. And then negative 9 times 4, that's negative 36. And when you combine the lines, the 4x squared comes down. The positive 8 with the negative 18, that's going to leave you a negative 10 of those x's. And the minus 36 comes down. Now, I was not stacking on the other ones because it's kind of pointless, right? I mean, if you only have 4 terms and the 2 middle you could combine, it's just as easy to write it out from left to right. But if you want to stack them, go for it. I don't really recommend stacking until you have a binomial times a trinomial, or a trinomial times a trinomial. Trinomial? 3 terms times 3 terms. So right here, when I distribute 2x times 5x, I get 10x squared. 2x times negative 4, I get negative 8x. And then when I distribute negative 2 times 5x, I get a negative 10x. And negative 2 times negative 4, that'll give me a positive 8. So you see 4 terms, it's not that bad, especially if you're only combining the 2 terms that are alike that are in the inside. The negative 8x and the negative 10x, you could combine those and you'll get negative 18x. What about the first term? Just bring it down, 10x squared. The last term plus 8, bring it down. That's your answer right there. So you could stack them if you want, or you could just leave them side by side. Let's jump to number 10. Again, distributing 4g times 2g. 4 times 2 is 8. And g times g is g squared, right? Coefficient 4 times coefficient 2, that's 8. Variable g times variable g is g squared. Let's distribute that 4g to the other one. 4g times 3h. Well, you have 4 times 3. Again, the coefficient 4 times the coefficient 3. What's that? 12. And when I say now the variable g times the variable h, it just stays the same, gh, right? As a matter of fact, when I write down gh, what that really means is g times h. So when you say g times h and you write g times h, that's perfectly fine. You're just rewriting what you had. Now let's distribute the 3h, the positive 3h times 2g. Well, 3 times 2 is 6, and h times g is hg, but let's write it in alphabetical order, which means we're going to get gh again. And last but not least, 3h times 3h. 3 times 3 is 9. H times h is h squared. There you go, 9h squared. And of course, the middle terms, even though it's not a single variable, it's a g and a h, this is also a g and a h. In other words, I have 12 GHs, and I have 6 more GHs. I could actually combine those. 12 GHs plus 6 GHs is a total of 18 of those exact GHs. Let me bring down the 8G squared and bring down the plus 9H squared. And I'm done. That's my answer. So even if you have multiple variables, it's just as easy. All you have to do is distribute one at a time. Distribute the 4G first, distribute the 3G or 3H second, and then combine the two middle terms. We finally get to something fun, like number 12. We have a binomial times a trinomial. And I definitely recommend stacking on this one. It gets a little ugly if you don't stack. You don't have to. But when I distribute t times t squared, that's t to the third. When I go t times 4t, that's plus 4t squared. T times 7, that's going to be 7t. And then positive 3 times t squared, that's positive 3t squared, but I'm going to write it under the 4t squared. That way it's really easy to combine. 3 times 4t, positive 12t. And again, notice that I wrote that 12t right underneath the other t term. Last but not least, 3 times 7, positive 21. And now it's just a question of combining like terms. And because it's lined up like that, it's really easy. The t to the third comes down. The 4 plus 3 is 7 of those t squares. The 7 plus 12 is 19 of those t's, and it's positive 19. And the 21 at the very end simply comes down. So even this one is pretty simple if you're organized and if you stack them. It would be it'd be a lot more confusing if you just wrote it out over here. You'd have 6 terms going from left to right. But because we stacked them, it's pretty easy to combine these two and get those answers. Let's jump to number 14. Number 14, fun stuff. Distributing the 3d times 2d squared, I'm going to get 6d to the third. 3d times 5d, I'm going to get what? 15d to the second. And then 3d times negative 2, negative 6 with the d. Now, instead of continuing my expression this way when I distribute the 3, I'm not going to write it this way, I'm going to stack them. So it'll be a little more organized and easier to do. So 3 times 2d, or 3 times 2d squared is 6d squared. So I'm going to go plus 6d squared. I write it right below the other d squared term. And then 3 times 5d, that's 15d, but I'm going to write that underneath my other d term, positive 15d. And last but not least, 3 times negative 2, that's negative 6. There are no other constants, no other numbers without variables to combine. So now I simply, since it's all organized, just bring this down, combine these two, get two answers, bring that down, and you're done. Final answer will be 6d to the third plus 15 plus 6 is 21 of those d squares. And then negative 6 plus 15, that's positive 9 left over. You have $6. No, if you owe $6 and have 15, you're still going to have 9 left over after you pay off the 6 that you owe. Bring down the minus 6. We are done. Just for funsies here, how would I classify this? First and last name? Cubic polynomial. Excellent. Cubic polynomial. Let's jump to number 16. Finally. Oh no, it's not that fun. It's just the same. Distributing a binomial into a trinomial. So here we go. 3r times 9r squared, that's 27r to the third. 3r times 6r, that is 18. R times r is r squared. And then 3r times 4, that's simply going to be 12r. Now I'm going to stack them to stay organized. Positive 2 times 9r squared, that's 18r squared. It is positive 18r squared, so it goes right below the other 18r squared. And then positive 2 times 6r, that is 12r. And it goes right below the other 12r. And then 2 times 4 is 8. And now let's combine them. The 27r to the third comes down. The 18 plus 18 is 36 of those r squares. 12 plus 12 is 24 of those r's. And the plus 8 comes down. And that's our answer, a cubic polynomial. We finally get to something more fun. Number 20. we have a trinomial times a trinomial. Now, if you don't stack, it's really going to get ugly, really ugly. Check it out. Distribute 3y squared times 3y squared, that's 9y to the fourth. 3y squared times negative 4, that's negative 4y, it's negative 12y to the third. And then negative 3y squared times negative 5, that's going to be a negative 15y squared. Now, the next term is my middle term, positive 2y, and I'm going to do that in blue. 2y times 3y squared, that becomes 6y to the third, and I'm going to put that underneath the other y to the third term. And then 2y times negative 4y, negative 8y to the second, or y squared, and you write that right below the other y squared term. And then 2y times negative 5, that's negative 10y. Notice that there are no other single y terms, so it just is there at the end. And now let's distribute the third term. Again, it's all distributed property. I want to distribute this positive 2 with a different color. If you're using the same color, this is really going to get confusing. If you're using different colors, it still looks ugly, but at least it's easier to understand. 2 times 3y squared is 6y squared. And you're going to write it underneath the other y squared terms. So 6y squared goes underneath the other y squared terms. And then 2 times negative 4y, that's negative 8y. And of course, I'm going to write that right next to the, or underneath the other y term. And last but not least, 2 times negative 5, that's negative 10. So if you didn't stack them like this, you would literally have nine terms from left to right. And you'd have to use circles and underlines and squiggly underlines to combine those terms. But because we have them nice and stacked, it's really easy to get to your answer. 9y to the fourth, you don't do anything with it. You just bring it down as the first part of your quartic answer. The second term, negative 12 plus 6, that'll give you a negative 6. And we are talking about those y to the thirds. Now right here, when I have negative 15 with the minus 8 and a positive 6, it doesn't matter which order you go, but you need to combine those. If you owe 8 and you have 6, you're going to owe 2, right? Owing 2 and owing 15, you're going to owe 17 altogether. So minus 17, well, let me do it in black, sorry. Minus 17y squared would be your answer when you combine negative 15 with negative 8 with positive 6. Now let's move on to combining the negative 10 and the negative 8. That's going to give us a negative 18 of those y's. And the minus 10 comes down. And that's our quartic polynomial. So this is as hard as it possibly gets. I would stack them to stay organized. Of course, you need to do all these. I just did the even ones. Bless you. Make sure you do all this homework because I am collecting homework on the day of the quiz. This Friday we're going to have a quiz on this stuff.